This is our just-in-time lecture over the most often missed questions from section 7.6 over the ideal gas law. All right, so just like one of the other recent PlayPosit lectures where I did not make a just-in-time video, you guys are still having trouble with significant figures. Keep in mind that a lot of times I'm going to tell you exactly how many you need to include. So what I saw most often was students were taking the negative 15 degrees Celsius, they were adding 273.15, and then they were reporting this as 258.15, which that is not three significant figures, that is five significant figures, okay? So the best answer for this one was 258 to three significant figures. Watch the prompts. This question asked you to calculate the moles of oxygen gas, so N was what we were looking for, given these starting conditions. Let me go ahead and fill in those starting conditions and then we'll work through the problem. All right, I've filled in the pressure, and we know that because R is in liter atmospheres per mole Kelvin, we really have to watch our units to make sure temperature is in Kelvin and to make sure our pressure is in ATM and to make sure volume is in liters. So we're solving here for N, which means that we need to divide both sides by RT to isolate that variable. So R's and T's cancel out. N is going to be equal to PV over RT, which is going to be our pressure in ATM. Our volume, 2.60 liters. Our R, 0.08206 liter atmospheres per mole Kelvin times our temperature in Kelvin, which is 292 Kelvin. Okay, so depending on how you plug that into your calculator, I did see some really large, crazy numbers, but you should have gotten 0.107747 and some change, which to three significant figures would be N equals 0.108 moles. So make sure that when you are putting this into your calculator, that you're doing 0.993 times 2.6 divided by, and put some brackets around this. The really large number I saw, I'm pretty sure that they wound up multiplying by 292 Kelvin. Also go through and make sure that your atmospheres cancel out, your liters cancel out, and your Kelvin cancels out. So you wind up with essentially 1 over moles, which becomes moles at the end. If you have any other questions over this problem, please put that on Piazza. All right, on this final question, I had gone ahead and drawn all of this out for you. So the goal here was to plug this into your calculator. And once you had it in your calculator, make sure that you were keying it in correctly so you could get the answer. We see that Kelvin's going to cancel out, liters are going to cancel out, so we'll get a pressure in ATM. And you should have gotten P2 is equal to 0.595 ATM. Again, I saw some answers kind of all over the board, so I think we need to consider putting in those brackets around what we're multiplying and dividing. It wasn't really a sig fig issue on this one. So again, if you're having trouble with this sort of a question, if it's the algebra tripping you up or the chemistry, regardless, throw this question on Piazza so I can get it answered before the exam on Thursday.